This demo will show how to use the scripts that will run the force-based submodeling instead of using the traditional displacement-based. So you need to initially have some problem that will have, in this case, a part that's fixed on the bottom surface, and then some locations here that, this represents the submodel, but there's some forces and maybe moments that are going to be applied to these surfaces instead of displacements to maybe all three of these locations. So in order to do this, you need to first have some name selections set up. In this case, I've identified two different name selections with CBDOF1 and 2. So those need to be set up beforehand, and they need to have a common prefix, in this case CBDOF. So once you've installed the scripts, you can either run it by going to Tools, Run Macro, or I have it set up through a button here. So then it prompts you for the name of the cut boundary file, where all the forces are going to come from. So that's going to be a space delimited file, and it's going to be a good idea to check this box to start off to view the input data. And if you do that, it'll bring up an Excel sheet, and this is what the data needs to look like. It's going to be node number, XYZ position, force XYZ, moment XYZ. So as long as the data is in this type of a format, space delimited, then you can read it in by browsing to the file, and you can view the input data. The name selection prefix in this case is going to be CBDOF, any letters that are common between the name selections that you're going to be using. So when I say OK, it's going to look at the first line of data from that file, in case the first node, XYZ position, and then it's going to find the name selection that is closest to that position out of the prefixes that we've defined, CBDOF. So that node could either be closest to this location or this location. So it's going to go through all those different nodes, find the positions, and apply them to the appropriate name selection. And if we had moments as well, then it would also apply instead of a remote force or remote moment. But this file I used doesn't have any moments in there, or they're all 0. So this finished. Now we can take a look here and see all the different remote forces that were applied to the model corresponding to the cut boundary loads and maybe the global model applied to this local submodel. And each of the remote forces are tagged with the name in which the data came from the file. So this is node number, and you can look at the XYZ positions, force XYZ, and just kind of verify the data if you want. So at this point then we can go and solve the model. And it finished. So now we can look at the displacements, the stresses, and it's probably a good idea to look at the reaction force from the constrained location. And the reaction forces in this local submodel should match up very well with the global model. In this case, these are equal and opposite the applied forces from the global model. So you can use this to do force-based submodeling instead of applying the traditional displacements to all the cut locations, and you can use this script to do it in an automated way. So thank you and enjoy.